Good morning. Good morning. Hey, somebody yelled back. You know, these flashing lights up here on these red sticks get a little distracting sometimes, don't they? It reminds me, my daughter lives in central Iowa, away from everything except cornfields, and their town has 922 people. Well, over the past 2 years, they've put around 100 windmills in the cornfields. And when you drive in between Des Moines and New Sharon, where she is, and you get over the hill, the little hill that's made up by the rubbish in the dump, because that's the highest point in Iowa, I think. But you get over that and you can look, and at night, you see about 100 red lights flashing in synchrony. Bang, bang, bang. And then one gets out. Bang, 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 bang. These lights here remind me of that. Just for those of you that didn't notice the lights coming on with their Vox switches. So, hope you all had a good time at the reception last night. And we'd like to thank the Aerospace Corporation for today's breakfast and breaks. Thanks, Ron. There he is, okay. And I'm going to do something a little different this morning. Just so that I know who they are, I'm going to ask our sponsors to stand up when they call their names so that you guys can recognize them also. So we've already talked about Aerospace Corporation, and then Aerojet Rocketdyne. They're here. Yeah, there they are. I'm going to be really embarrassed if somebody's not here. BWXT. Dynetics. Tim Vista. GE Aviation. Oh. Yeah, they're great guys. We may have somebody here from Maxar. Moog. Not pronounced Moog, Moog. Thanks, guys. Fred and Whitney. Great. Yeah, they're over there, yeah. Zen Technologies. Gentlemen, thank you. And our media sponsor, Space News, who I don't think is here. I haven't seen him. All right, so before we go to our first speaker, we want to give a special thanks to Maxar for being our education sponsor this year. They sponsored 10 student registrations. So 10 of the students that were here, some of you saw them last night, but 10 of the students that came here were done complimentary of Maxar, so thank you. And now I get to introduce someone I knew a long, long time ago, because I used to attend some of the meetings he used to attend, and still does, Comstack. Back then, he was working for a Bigelow company or something like that, and then he came over to Maxar. And I learned one thing way back then. He was in a meeting one time, and he said, if you ever want to get me to one of your conferences, make sure you schedule it adjacent to a ball game, a ball field, something like that. So we tried to put this meeting on top of the All-Stars game just to get Mike here. Mike Gold.
And I feel terrible. I missed my one chance to go to an All-Star game, but thank you to AAS for that scheduling. That was amazing. Well, look, I missed the Major League Baseball All-Stars, but I get to be here with the All-Stars of Solar Electric Propulsion, right? Who cares about the ball players? And who are those people? I'm looking at them, right now you're going to hear from Michael Barrett, Brian Smith, Michelle Gates. These are the people who, during very difficult times, kept the torch lit for solar electric propulsion, kept it moving forward. Let's give them another round of applause. Now, I'm obviously biased, but I think solar electric propulsion has the potential not only to take us to the moon, but to unlock the rest of the solar system to humanity. And this is why Gateway is so important, because it's not just enabling Artemis and putting the first woman on the moon by 2024, but will also open up Mars and Europa and even more distant destinations for human space exploration. And I also want to compliment the Glenn team, and especially Kathy, if she's out there. There she is. for running an innovative procurement process that instead of dictating solutions to the private sector, allowed companies to come up with their own strategies to meet the agency's needs. I believe the BAA fixed price, tailored FAR approach, and that's a sentence only a recovering attorney can love, will carry NASA into the future and is equally as important as any technological advances that we're going to make. So don't hate me, engineers, for saying that. However, whether we're talking about the technical innovations or new procurement methodologies, we need to demonstrate the validity of both. And we at Maxar are proud to be working side by side with our friends at NASA to execute this first step on the Artemis journey with the power and propulsion element. I can assure you that we see the PPE not as a contract, but as a mission, which we will defend aggressively and put our blood, sweat, and tears into successfully completing. I'm proud that we're going back to the moon. I'm proud that we're going to put the first woman on the moon, and I'm proud that the road to the moon goes through Cleveland. Now, they say a picture says 1,000 words, so I'm sure a video is worth 1,000,000, so let's roll the tape, please.
We are going to the moon to inspire the next generation, to advance our understanding of the universe so that we can share the benefits with all, here and now. We are going to use partners who see the critical roles they play as nothing short of advancing the cause of humanity. Today, we take the next step in the Artemis program towards our Moon 2024 objective with a partnership that is the first of its kind.
Maxar Technologies will launch and demonstrate the foundational element of Gateway, the power and propulsion element.
We believe in the need to accelerate the advancements of science, technology, and human exploration. The Gateway is our lunar orbiting station and is a critical piece of sustaining our presence on the moon. As a hub for science, technology, and human travel, the Gateway will allow us to reach areas of the moon that have never been accessible before. The Gateway will be built in 2 phases. The first is a minimalistic design that will prepare the way for human landings by 2024. The second phase will see the addition of modules that expand the habitation and long-term science capabilities by 2028, thus enabling sustained missions to the moon.
The initial element of the Gateway and the focus of this partnership is the power and propulsion element, or PPE as we call it. This element will be the source of thrust, power, communication, and the foundation upon which all other modules are added. The unique nature of this partnership allows us to accelerate our lunar return. Together, we are poised to meet a launch date in 2022. Initially, the PPE will be owned and operated in orbit around the moon by our commercial partner. NASA will take delivery of the element after a successful demonstration. The systems developed here will drive down the cost of future lunar exploration and enable sustained missions on the surface. It will also demonstrate what is possible for future missions to Mars.
One such example of this focused development is the advancement of a proven technology with the PPE's engine, a solar electric propulsion thruster. These thrusters were pioneered in the 1960s and have proven to be incredibly efficient and reliable, with hundreds of thousands of hours of successful spaceflight operations. Specifically, SEP systems are known for their fine control of spacecraft due to their low thrust, their ability to fire continuously for years at a time, and their ability to allow a craft to stop, start, and change directions to visit multiple destinations. This partnership calls for the demonstration of a new electric propulsion system on Gateway's PPE using advanced Hall thruster technology. The Gateway PPE will provide 3 times the power of current solar electric propulsion systems.
Our return to the moon is now well underway. Maxar Technologies is now tasked with bringing their unique power propulsion element design to life, launching it into orbit around the moon, and demonstrating its capabilities to NASA.
Their success will put into place the first element of our sustainable return to the moon. We are proud to welcome them to our mission. Together, we are going.
For more information on the Artemis program and our plans to land the next man and the first woman on the moon in 2024, visit nasa.gov/moon to Mars.
Thanks, Mike. And it's going to be exciting as you go through that. Have a little bit of housekeeping. The first thing is bathrooms and things are out there. Lunch will be out there, or we'll get it out there when it's lunchtime. But the most important thing is that if you're like me and you didn't memorize the password and memorize the way to put in your electronic questions, we have it up there on the screen. I will ramble for a moment or two to let you write it down or take a picture of it with your phone. I usually just take a picture, and then I forget to delete them. And my wife says, "What's this on your phone?" I was trying to figure out whether Mike wanted to be called Michael or Mike. It's Michael on my script, but I saw it Mike on the video, so Mike must be proper. It's Michael, Michelle. I get confused sometimes, a lot of times. But anyway, so Michael Barrett has been a propulsion engineer, a subsystems manager, a chief engineer on things like shuttle, station, Prometheus, crew exploration vehicle, Orion service module, Altar, and now Dr. Michael Barrett is the manager of the Gateway Power and Propulsion Element. And we are really excited to have him tell us about this, from the top. This soon after the award, I need to learn some things. I'm sure there's some things out there you don't understand. It's going to be a technical challenge. The business case is really interesting. So Dr. Barrett, there he is. Okay.
Thanks. Actually, you took some stuff with you. Yes, you did. There we go. Thanks. I do, but just in case. I believe in redundancy. So that's all right. All right, good morning. First of all, thank you for coming out this early. I actually expected the room to be half empty or half full, or the room to be twice as big as we need, right? But for those of you, if you are staying again tonight, then and you're here now, the folks that roll in at 10 o'clock, make sure you ask them the directions to the bars at the flats. Okay, so wouldn't want you to spend another night in Cleveland not knowing how to get there. Before I start, I would like to acknowledge a couple folks that Mike also mentioned. First, Kathy Schubert, who's in the back. Kathy led our procurement team for the power and propulsion element, and I've got a chart that actually she provided for me here in a moment, a little bit to talk about what the innovations were in the acquisition process. And then also Dr. Michelle Gates, who's right here, was our source selection official for the PPE and also the program director for PPE at headquarters. All right, let's see if the charts are ready. Okay. So it is genuinely an honor to be asked to speak at the inaugural John H. Glenn Symposium. I put the H in there for a very specific reason. I've been for a long time trying to sell the high reliability SEP for human lunar exploration. Give you a second. That's Herschel, right? Which was John Glenn's middle name, and I have not been able to make it stick, so it was just one last poke. All right. To be honest, though, we have been working on the equivalent of the power and propulsion element for a long time. This is essentially the third manifestation over about 10 years. It started as the desire to have a bus-level demonstration of solar electric propulsion in that 50 kilowatt class that was mostly driven by advanced studies looking at what do we need to prepare for Mars. That was about 10 years ago when we started that. It did end up as a project, the SEP project, Solar Electric Propulsion Project under STMD, and that was prior to its second manifestation, which was then the Solar Electric Propulsion Module for the asteroid redirect mission under ARM, and then 24, 30 months ago or so, we took essentially the SEP module for ARM with some tweaks and then turned that into the PPE for Gateway. And so I'm just going to briefly give you a summary of where that's at, what that's going to do. I'm not going to talk about the Gateway configuration. You heard a lot about that yesterday and then saw the video again, so I think that gives you the context. I will just remind you, PPE is the first element, right? So we've got a 2022 launch date, development cycle about between 30, 36 months, and so that 2022 date will be the first element in the Gateway architecture return to the moon. So in terms of PPE itself, even 10 years ago, the point was we were trying to do this bus-level demonstration and leverage the advanced technology development that had been ongoing literally for decades but at this higher power level for the electric propulsion strings, somewhere at the time between 10 and 15 kilowatts is what we thought the string power would come out to be. It turns out now it's at 12.5 kilowatts, right? That's the AAPS project that Aerojet is working for NASA to develop this 12.5 kilowatt string, where the application is the power propulsion element. The first application is the power propulsion element. That element will launch in 22. It was set out, again, from the beginning to leverage U.S. industry capability, both at the technology level and now at the bus level. The bus level acquisition is being developed through a partnership with industry. I'll talk more about that when I talk about the acquisition process and the technique that was used. And then getting this integral bus demonstration of SEP so that it feeds, so that it satisfies the need for the lunar exploration but feeds forward to Mars was absolutely the key. When we set up the acquisition, this was unique in that it was not your traditional FAR Part 15 for the lawyers and procurement folks in the room acquisition. We did not levy a full spacecraft set of requirements on industry, right, and ask for people to bid to those requirements. Essentially, in-house, we'd had these development and test objectives that we wanted to do to demonstrate the technology. And we took that, developed a full spacecraft spec, or the equivalent thereof, had about upwards of 500 requirements, and then slowly started to rip that apart, essentially. Dave Manzella, our chief engineer, led a review where we pulled out, as soon as we got off of a government launch, then we dropped about 200 requirements. When we said, you know what, our partner is going to own the spacecraft, they're going to own the launch. So we dropped from 500 down to around 300, 350, somewhere in that range. Went through that entire list in a very detailed way and said, look, this bus for this demo is supposed to be based on a commercially available product, right, or commercially available capabilities. If we didn't specify this as a requirement, wouldn't they come up with it anyway? And line by line, through those 300, 350 requirements, the engineering team went through that and came up with, here's the 125 requirements that are unique, that a normal spacecraft developer and provider probably would not come up with because they were NASA unique needs. So then that's what went on contract, or went on for the RFP. And then as part of the proposal, the offerers had to fill out the rest of those requirements and say, here's your spacecraft, full set of requirements, draft, right? And we use that as part of the evaluation criteria. But doing that really established this partnership, right? So we brought our objectives and our NASA unique requirements. They were to bring their own objectives for hopefully the commercial application of serial number 2, as I talk about it a lot, right? It doesn't show up as one of our top objectives, but it has been and will continue to be one of my personal ones, that serial number 2 be applied for a commercial application. That's full success for me, right, for PPE. But it was a partnership. Certainly wanted to get in space relevant or environments demonstrated, again, at the system level, not only the environment from the application, whether it's cislunar or maybe GEO for the commercial application or the Martian eventually, right, but also the induced environments that SEP will also, this high-power SEP system would have for the rest of the spacecraft that we can really only get with the space level demo, bus level demo. Autonomous operations, that's something actually that we knew our industry partners would have a lot more experience than we did, right? So we were going to rely on them, but wanted to demonstrate that. NRHO, by the time we came out with the PPE solicitation, had been selected, right, for Gateway and for that architecture. So to demonstrate that insertion into that NRHO. And then as part of the demo, we had to acquire the data that was necessary so that NASA could certify PPE for use on Gateway. And again, that's because we've set it up so that we do not own PPE. There's no DD-250, right, prior to launch. In fact, it is owned by our partner through launch and through the first year of demonstration operations, after which NASA does an assessment based on acquiring those data products that we need for certification, and then NASA would take ownership after that. That should sound a little different, right? Hopefully. So you can imagine folks like Michelle at headquarters leading the charge and Kathy working with procurement and legal. It all seems simple now, but it took a good 20, 28 months, right, to go through all of the hoops to convince people, A, this was a good idea, it was worth pursuing. And Gerst himself always calls PPE an experiment, right? I'm pretty sure he's going to continue to call it that. And so we're going to do everything we can to make his experiment successful. So obviously, Mike, right, came up. Maxar was selected May 23rd as our commercial partner for PPE. And so just briefly, I'm going to give you a summary of what their design concept is. And again, it's really important to understand that we had 5 offers that came in, and it was not an apples-to-apples comparison. We set it up that way on purpose because we knew through study contracts that we'd run, through RFIs, other ways to gather information from industry, we knew that there were different business plans out there for what high-power SEP would be. It's really a perfect storm for us, right, in terms of the technology maturation was at the right point in time for the higher power STEP. We knew that industry had uses where they're moving over to all-electric spacecraft in the commercial world. DoD and the Air Force, and now hopefully Space Force. Don't ask me any Space Force questions. I won't be able to answer them today either, as they didn't yesterday. But they also have interest in this in terms of its application as they deploy large assets in the future. And so having all of those interests, and we engaged with all of those parties, and we knew that the offerers were also aware of all those different possible applications, and so we knew their business plans and their objectives and their requirement set were not going to be the same. It's why we had a unique procurement. We set up a deviated FAR Part 35. And so what that meant was that we set up an evaluation criteria that still had to be rigorous, but it had to allow people to offer different things so that we could compare them for overall value to the government of what we were trying to do with ultimate application of PPE for Gateway. So the concept that's been selected, just hitting some top-level performance capability, right? So in terms of power, it's greater than 60-watt capability beginning of life for the arrays. The Maxar design uses DSS arrays that we initially started here at NASA, Glenn, in terms of an advanced development several years ago under a project with STMD. And then that project had actually been intended to move into a commercial, call it phase 2, with flight. And we didn't have to do it because Maxar teamed with DSS to commercialize the arrays, the ROSA arrays, as soon as we were done with it. And Meg, are you here? Meg had led that project when we did the array development initially, and then that flowed right into the technology maturation stream that then eventually led to the selection for PPE as well. That was really nice for us because, again, that initial NASA investment to burn down the high-risk elements, that is an inherently governmental thing to do, was successful, so then it was commercialized and they picked it up on their own. So now it's going to show up as a NASA benefit, right, coming back to us as the PPE for Gateway. In terms of propulsion, Maxar is going to leverage 2 EP development strings. One, the 12.5 kilowatt string that Aerojet is working on for us and for STMD, and then also another in-house development they have with their own PPU and a Busick thruster. That's at the 6 kilowatt level, that string. It was a unique aspect to the spacecraft that gave us dissimilar redundancy in some cases for some functions, and so that was an attractive option as well. In terms of COM, the PPE, it's kind of misnamed. We left COM out of the title. If Sandy's here, I know, and I see Rich, so sorry. So it is power and propulsion, but our third major function for Gateway is communications, right? Both S-band and Ka-band, and the capability of hosting an optical comm payload once we're on orbit, which would be part of Gateway robotically installed. G&C, this was also one of the strengths. So because of the way Maxar already flies their 1300 bus in their spacecraft, they have a lot of autonomy already in their process, and the hardware associated with that and software associated with that, they deviated as little as possible to show how it fit for the PPE application. So in terms of their overall G&C, it was a smaller deviation from what they normally do, which really allowed us to benefit from that commercial expertise. Gateway interfaces. Here's another one in terms of our requirements that I mentioned. We levied 125. What we didn't levy in the procurement were things like NASA design and construction standards, NASA SNMA requirements, right? Those were provided as reference, both the design and construction and the safety and mission assurance requirements. Interoperability standards that we all participated in developing with our international partners so that we're sure Gateway is going to be successful. Those were actually provided as reference for the PPE acquisition. You can imagine the discussions that we had to make that happen, right? Again, the point was we wanted PPE not to deviate from the commercial bus, to minimize that deviation, because what we wanted to do was take the 100, 200, right, 1300 bus demonstrated reliability examples and not force them to do something different, because that would be initially starting over with a new process, right? And then we would not be able to rely on that demonstrated reliability. That was very unique for PPE in terms of the gateway philosophy and approach. But that is where we ended up. And so Maxar, as part of their proposal, then all those things were provided as reference, and they identified here's where we're going to be compatible with what, if they'd been levied as requirements, we're going to meet anyway, right, as part of the proposal. And then on top of all of that, literally, the PPE on the commercial launch that they're going to provide has a capability of 1,000 kilograms, potential, right, teaming for a lander opportunity, or also for payload. That was an augmentation. So they augmented that. They augmented power capability, and there were some other aspects of the proposal that were above and beyond the NASA unique requirements that we deemed valuable for the government. Anyway, so we are incredibly excited, right? Again, it is a short, right, development time in terms of when you just tell somebody, oh yeah, 30, 36 months, right, we're going to launch, but it's not out of family at all with what industry is used to doing for deviations from their buses. So our key is, how far do we deviate from what they've done? And that was one of the strengths in the proposal, that they have a PPE solution that looks very much like a 1300 bus. The areas that are different in terms of the higher power EP, the higher power rays, the thrusters, were things that they wanted to do as part of their product development commercially as well anyway. And certainly, Maxar's experience with more than 30 solar electric propulsion spacecraft, right, and that implementation of new technology in those spacecraft and the demonstrated reliability that they've had was also a key factor in their selection. Just a little more detail about the acquisition, because, and although there's some stuff going on now that I'm like, well, I thought we were innovative, right? And so, but I still feel like we were the spark, right? So Kathy, I still think we were the spark. But at the time, I can tell you this felt sporty every time that we tried to explain why we were doing it and what the rationale was, right? So I've mentioned the partner owns this. We don't have a DD-250 prior to launch. They're going to launch the spacecraft. They're going to do the demonstration, and then NASA has the option to take ownership after that first year and after a successful demo. I already mentioned the deviated Farport 35. The main point of that, again, was so that we could have different people offer different spacecraft based on different objectives and different requirement sets, but still have a rigorous way to do the evaluation and determine value for the government. It is a firm fixed price contract. Again, for a spacecraft development, we're getting better at this. NASA is, right? Certainly for services. For a development with the intention to eventually own, this is I'd say still trailblazing for us. But again, commercial is used to this, right? Industry is used to working this way with their customers. So we're actually learning from them. We had a lot of industry feedback up front saying they preferred firm fixed price for the development. So we've done that. I mentioned each party brings their own objectives, leveraging the maximum use of commercial products. I went through the story on the unique set of PPE requirements. Again, we started out with over 500. And after we got onto a commercial launch vehicle and then said, what does NASA really need to specify for functional performance, it got down to 125. Right? We'll see what the actual final spacecraft spec looks like. Right? In terms of insight, this is also something that as part of the proposal, we asked the partner, based on their commercial practices, please give us a draft insight plan for the government. And that was because it's a firm fixed price contract. You can imagine if you're the offerer trying to put a proposal together, you need to know just how much is NASA going to get in my knickers, right? I mean, they had to be able to scope that. Otherwise, how could you possibly sign up with the risk on a firm fixed price contract? So they made those plans part of the proposal. We evaluated those plans about whether it met our expectations, right, for the level of insight that we needed. And that was part of, again, part of the evaluation criteria, but very different, right? And I think we still, right, even at the kickoff, I had a lot of people come tell me how much on the industry side it took people a while to believe whether or not NASA's really going to work this way, right? And so we still have to demonstrate it, and we have to demonstrate success, but that's exactly what we're doing right now. We required a signed model contract to be submitted with the proposal. This happens a lot, I think, in FAR Part 12s, right, where it's more a services thing or facilities thing, or those kind of acquisitions off the shelf. A little unusual on a spacecraft build of this size and magnitude and complexity, but that was provided. It was a lesson learned we had also from our studies. Worked really, really well. It gave us the opportunity to help them as the proposing team and capture team work through their corporate reviews, right, with their legal and their procurement, and they could see the contract clauses that were there. So when we got the proposals in, we allowed them to take exceptions to the clauses, but they had to explain them. right? So we could see exactly where we were at in terms of understanding what were issues and what were not. Where those are the kind of things that you might not find until after either a definitization period or a negotiation period, right? Something like that. We got that information with the proposals so that we could do that evaluation right up front. I mentioned the high degree of interaction. We believe that to be true. I think the industry folks that were involved with it would agree. I mentioned RFIs. We had formal study contracts with industry to lay out the design space and the options and to help socialize with them about what we were planning on doing with this different approach for PPE. And then got lots of positive feedback at our industry day in the formal forums that you would normally have in a procurement. And then we also tried to make it very clear NASA intended to try to award without discussion. We wanted, because of the nature of the materials that we asked to be provided by the offerers, our intent was to go through the evaluation, identify whether or not we could live with the clause exceptions they had in their contract, make sure we looked at the insight plan, was that meeting what we'd drafted as our own insight plan internally, and based on all of that, do a selection and award without discussions, right, to minimize NASA's requiring additional time on the development process. And that's exactly what we did. So we are really excited to be working with Maxar. The expectation, again, is it's a 36-month development, depending on how we finalize what some of the risk mitigation activity might be as well. But it's a 22 launch. That's in family with what they do commercially. So at this point, it's our job not to get in the way. We're going to watch what's going on, but it's very much a partnership in terms of understanding what we need and what they're doing to satisfy those needs based on what's already established in the contract. I don't know if there's time for a couple of questions if anybody has it, but that's all I had.
Thank you, thank you. I don't see any questions on the conference I/O. Does anybody in the room have a question? Anyone? If not, oh, Carol.
Good morning. Hi, I'll ask a question. You mentioned you had earlier study phases with the contractors. Can you just mention about how long those were and like what was the funding for that level?
Yeah, the funding level was in the tens of thousands of dollars. Somebody can help me with the prior appendix studies, right? And honestly, you'd think I'd remember right off the top of my head. Were they 6 months? Thank you. Right, so $500K, 6 months? 4. Felt like 6. No, but we did that up front, and honestly, we debated whether or not we should do it, right? Because at that time, we still knew, here's the timeline for Gateway. So there was a lot of activity that we were running in parallel, and Dave Yermy, he's my deputy, and Dave ran those, right? Which is why he definitely knows the numbers better than I do on it. We had the debate internally. Should we really spend time over here? We think we know what we want, right? The NASA unique requirements didn't change very much based on that feedback. What it did is it allowed us to learn a lot about what the industry plans were, right? So that it allowed us to ask questions about the procurement approach that we were going to take. And are you comfortable if we're asking you to bring objectives and you know that we don't have all the requirements specified, we're asking you to add? Those were really valuable sets of feedback. On the technical side as well, it allowed us to move from what was ARM, which a lot of those industry study awardees were also involved in the ARM proposals and studies. And it allowed us to show them, these things are similar, here's what we already know are different. What do you think, and how much of a perturbation is this for you? And we also got the feedback from a technical perspective, how those differences were going to deviate from their bus capabilities, right? So that was huge. It helped us feed the early requirement sets for Gateway as well, in terms of controllability of the stack, what a commercially-based bus could do, which we're all now going through refinements on, but that initial look at that all came from the study contracts. We just this week had a meeting where we said, you know what, we debated whether or not to do them at the time, and they were really valuable. Yeah. Okay, thanks.
Thank you very much. Appreciate it. Thank you. Very much. That was excellent.